Morning, everybody, and welcome to JCON Online World. Welcome to Eclipse Store Summit. This talk is about introduction to Eclipse Store, Databaseless, high performance Java native persistence. This is a kind of like high level talk about Eclipse Store. I know who have already heard about Eclipse Store or Microservices before. This is some overlapping, but I try always to put some new information, latest information, and in the talk to give you the latest information. So Databaseless, high performance, Java native. So this is not only putting all the buzzwords in a session title. So let me explain this. First of all, Databaseless is really, it means you store data without a database. You don't need the database at all for your data processing. I mean, high performance is pretty clear. What does Java native mean? So storing data is actually a job done by a database system. With Java native, it means that this is the Java way to store Java objects persistently on disk. And sometimes we have some more buzzwords in our session title. So something like microservices or cloud native, and this is all of this is really true. So it's great for building microservices or to use it with microservices and for cloud native application, which means applications that are built for the cloud to run perfectly in the cloud. My name is Markus Kett. I'm CEO and co-founder of MicroStream, the company behind the Eclipse Store project. So because of we started the project, we run the project, but of course it's an open source project, it's an Eclipse project, and all of you are invited to contribute, to join us, to support us, and also other companies are invited to support the project, to benefit from the project in the end. So I'm working in the Java community or in the Java space for more than 20 years now. So we started with almost 20 years ago with a Java IDE. So we wanted to build and to provide a Java IDE that today we would say this is a low-code development environment. 20 years ago, we talked about 4GL, rapid application development. So this changed over time, but an IDE that simplifies building applications. So this was our initial project, and we had a great GUI builder based on Swing, so it worked well. The problem and the challenges we had was database programming. In the end, was very complicated. So to show, to query a database and to show data on a screen, this was the biggest challenge. And so we worked on database tools also for almost 20 years. And then we have migrated everything to Eclipse. So this was a great change for us. So when we talk about migrating and renewing, modernizing applications, about the risk and the risks and what decisions have to do, and so that it's complicated. I know exactly what you're talking about when you say so I have to modernize a monolithic application. This is really a good challenge. I know exactly what this means. So we put a lot of money in this project to migrate everything to Eclipse. So this was the reason why we worked on the JBoss Hibernate tools. So sometimes people tell me, "Hey, Markus, you do a little bit too much database bashing." But is not. So we worked on database tools for more than 15 years. We worked on the Hibernate tools. So we love database programming. We love all of this stuff. Otherwise, you can't do this. But of course, we had a lot of challenges. And this leads us to a new idea. And this leads us to the initial MicroStream project. And there was already a question in the chat: what's the difference between Eclipse Store and MicroStream? MicroStream was the initial project. And actually, this is not true because of one of our developers, Thomas. He started the project actually 10 years ago, and this was not started under MicroStream. So 4 years ago, we founded the company, and we called it MicroStream. Then from then on, it was a MicroStream project. We open sourced it, and now we donated the code to the Eclipse Foundation and continue development the project under the name Eclipse Store. So we choose the new name. It's because of legal rights. So you have to donate the name also, or you change the name. So this was the reason why we changed the name in Eclipse Store. But I will tell about this a little bit in more detail in other sessions when we talk about what's coming up. So Florian will have a talk today. What's coming up in the future, which features are already scheduled or planned or in a pipeline. So with my team, we're working on various open source projects for many years already. But now let's talk about a little bit more about Eclipse Store. What's the reason for all of this? Why should we care for another persistence? With big data, it began with big data. So with big data, the amount of data has been exploding, and this increases more and more. So with all of these modern applications, AI, machine learning, with virtual reality, blockchain, so more and more applications. We see more and more applications consuming, connecting, processing, and storing more and more data, and more and more companies have to do that. So so data is the new gold standard. So everything is about data, of course. And many years ago, it was very easy to handle data. The amount of data was not that much. We had just to store data on our local machines and share some disks or but now we have to distribute data globally. We have to we need real-time applications. So we need best possible performance for all of this. Imagine there is an AI solution, machine learning algorithm. So it needs best possible performance. So the better performance is, the more efficient, the more powerful your AI or machine learning algorithm will be, of course. So, and it's not only AI machine learning, it's also IoT, but it's also e-commerce applications. If you book a flight, so then mostly you have to wait for all these applications. So when I check in a hotel, mostly the people tell me, "Oh, system is broken. Sorry for that." So yeah, we have to wait 2 minutes, no problem. So it's most of these database applications are too slow, and this is not a great user experience, right? And then we have the data storage costs. So we always talk about, oh, our cloud costs are skyrocketing. So we run out of money because hosting our applications in the cloud is expensive, and the costs increase more and more. And of course, convenience. We are all developers, and so convenience is very deciding for us. So for decision makers, is more the cost case. For developers, more how convenient is it to use it to implement software, and database programming. So this is my personal opinion. Database programming is really complicated. And we wanted to change this. And the question is, why? Why is it? What's the problem? Why is it so complicated? And I will talk a little bit about this. But first of all, with Java, we can do all of this. And this is what I'm mostly talk about. The power of Java. On all conferences, we talk about, yeah, we love Java. So you hear this all the time. I know. But this is really true that Java is extremely fast and performant. So we have the JIT compiler. And 2 weeks ago or 3 weeks ago at Devox, Brian Goetz said, so with our JIT compiler, we can even outperform C. So I hear from many potential customers or new customers all the time, is Java really fast? So I mean, I heard that Java is slow, it's heavy wide, blah blah, and it's because of I heard this 20 years ago. But with the JIT compiler, it can really be faster than a C program because of it. The Java program gets optimized constantly through runtime. This is not possible with C. And by the way, the same with native images, but we have the chance to really create native images with GraphQL. So there are a lot of different technologies we have in Java to build really fast applications. And when we talk about fast, so I grew up with C64. So if you ever heard a podcast with Adam Bean, he mostly says, how did you start your career? And so he asked me also, how did you start your career? Of course, I had a Commodore C64, and I started with basic programming, and okay, I started with gaming. But then I learned to program with basic and then assembly. I grew up with assembly programming because it was super interesting, and the performance was great. And we learned that instructions are executed in nanoseconds. It takes only nanoseconds for some instructions to execute. So if you have a really bad algorithm, then it should be at least executed in microseconds. So we talk about microsecond response time when we talk about the performance of a Java program. This is really fast. So Java is really prepared for all of these modern applications. So we don't have to talk about this in more detail. But keep this in mind, please. What about data structure? This is very important because of all people tell me all the time, so the databases are built for storing data. Why the hell won't you change this? So what's the reason for that? We have the databases. Yes, that's true. But the databases, they provide their own database-specific data structure. And this is the reason why they are built for a specific use case. For example, the time series database is built for consuming and processing sensor data, for instance. A graph database is built for processing really complex data structure. Graph database vendor probably will tell you this is super great for complex data, but if you consume sensor data, it might be not a good choice for you. In Java, we don't talk about what actually is the best data structure for our application. What are the best data types? So we can deal with all of them. We can consume sensor data. We can store simple lists. So we have collections. We have graphs. We can have really complex graph with circular references. And the new vector stuff is coming up. So dealing with vectors is not a problem. It's not an issue in Java. So because of we have an object model, we have all these Java types collections and so on, which means we have already a multi-model data structure. And the modern databases, only a few of them, they promote themselves as we are now a multi-model database. But Java is a multi-model, or provides a multi-model data structure from the beginning. We have objects, we have object graphs. That's great. And the same with searching. We have Java Streams API, for instance, for searching and filtering in memory, searching object graphs, and the performance is absolutely incredible. If you search, let's say you have terabyte data in memory, and you have really complex structure of your object graph, and then you can browse and you filter and browse through the object graph. It's a question of sometimes nanoseconds, mostly microseconds. So here we talk about really microsecond response time, microsecond query time. And when we talk about the performance of databases, we talk about milliseconds. It doesn't matter what database we are using, even of course the NoSQL databases and the in-memory databases. The response time or the performance of in-memory databases also we talk about milliseconds. So microseconds versus milliseconds means factor 1000x faster with Java. So the only thing missing in Java is I cannot store data. Why? I mean, so the databases were invented in the early 1950s, and the relational model won the race. So in the 1980s, the relational database system they won, and so they are dominating the market. So relational databases were existing already when Java came up. So of course there was no question that we store data with the database. So, and Java is an object-oriented programming language. So how to store complex objects in a relational database? This is complicated stuff. I will show some slides. So, and because of it is complicated, it leads to further challenges. Our vision was, no, stop. I will talk about my personal vision 15 years ago. I thought I had the dream of actually the hardware should care for persistence. I want to build an application, write it in Java because we're Java developers. I can do everything with Java, and actually we should or let the hardware care for how to store data. So why not inventing a kind of like memory that is able to store your data persistently? So, and people told me this is bullshit. So this is not working. But then I was so surprised when Intel came up with persistent memory. So this was awesome. So because of now the dream should become true. So you write data in a memory, or you process data in memory, but at the same time it's persistent. Great. So I can skip all of this complicated database programming. But in practice, was not the case because of persistent memory is still very expensive in comparison to DRAM. So you had to push data from your DRAM to persistent memory. So, and it's pretty much the same if you use persistent memory or if you use a hard disk drive. So there must be a piece of software that managed persistence. So, but then the vision was, we need a software that cares for persistence, but not the framework. Actually, the environment should care for persistence. And for Java, it is the JVM. So actually, the JVM should care for persistence. I don't have to deal with all of this stuff. This was the initial vision. So actually, we had to run MicroStream as a JDK project. But at this time, we were not involved in the JDK process, so we are not familiar with the process. So we started a framework for our own. And this is really still the vision. So, and this is actually what now Eclipse Store is, in a nutshell. A framework or a library that runs deep inside your application. Actually, it should be part of a JVM, but it's not. So we need a dependency, a library that cares for everything behind the scenes. And this is actually what Eclipse Store is. And there are three main benefits. So if this is possible, then you can process your data with Java. You can write your program 100% in Java. And processing data in memory with Java, we have learned it's around 1000x faster than a comparable database query. We don't need a database at all, which means we save up to or more than 90%, sometimes 99% cloud data storage costs. And we do not talk about license fees. And it's a pure Java approach, which means there are no new rules to learn. There's no new database stuff to learn. No new query language or data structure. It's pure Java. It's core Java stuff. And this is daily business for you guys. This is what Eclipse Store is, and it's now available as a final release. We are super happy and proud to announce that we split the MicroStream project into two projects. One is the MicroStream, was the MicroStream serializer. It's now called Eclipse Serializer. And as I mentioned, MicroStream Persistence is now Eclipse Store. And both projects are available as a final release. It's also already well integrated with Helidon, which is a very popular microservice framework. And thanks to the Helidon team, they were the first to integrate MicroStream in their microservice framework. Also, Micronauts, MicroStream, and now Eclipse Store is well integrated with Micronaut. And Sergio has a talk today. He will show how this works and how you can use Eclipse Store with Micronaut. And this is really a beautiful integration. Join this talk in the afternoon. All right, and here back to the problem. Because this problem was this problem drove us crazy for many years, because we wanted to simplify database programming with Java. When we were able to simplify it, and it is possible, then it became slower. When we tried to make it faster, and it's possible, but then the complexity explodes. Why? It's because in Java, everything is an object, and we cannot store complex object graphs seamlessly in a relational database, because the data structure is completely different. So we need a mapping. So through runtime, we have to generate SQL instructions, send it to a database. The database returns a result set, It's a list of values. You get back a list of values. That's it. So, and your Java program, your Java application wants to consume objects. So we have to generate objects behind the scenes. And this is done by object relational mapping frameworks like Hibernate. And it works great. It works really great. But the problem is creating the object behind the scenes is a performance killer number one. You can use an in-memory database if you like. But the object relational mapping will kill your performance. So it's not the fault of the Oracle guys who built a great in-memory database, obviously. It's the object relational mapping. It's time-consuming. It leads to expensive latency, and this kills your performance. So what developers did, so we have great ideas, of course. So the problem is fixed. Just add a local cache. So with a local cache, you're able to accelerate your database queries. So you add a cache, but you add complexity. So yeah, now I have to deal with cache configurations. And many developers struggle with cache configurations. And databases are very expensive in the cloud. Why? Here's an example. If you want to run PostgreSQL as a service at AWS, it costs around $5,000 per year. One guy of my team, Timo, said, "Hey, Markus, this is not true. This is really cheaper." So I can. So probably you'll find a configuration that is really cheaper. So I choose a machine here, 4 CPUs, 16 gigabyte memory, cost you $5,000. Probably you'll find a configuration where you pay only for $3,000. Maybe. If you need more, if you need replication because you need high availability, you want to share the load, distribute the load, you need more nodes, your price will double, will triple. All right. But we talk about some $1,000 per year. So because of you need computing for a database server, the modern databases are server databases. So you need computing resources plus storage. Storage is really cheap. Computing resources are expensive. And in a distributed environment, the complexity will explode. So because now we distribute our application, we run the application on multiple machines. We have we run an application cluster. We want to scale horizontally. Now we have a problem with consistency of our data because of if a user changes some data on one of these nodes and store it in the database, then this node and the database are in sync, but all of the other nodes are not in sync with this node and with the database. So the solution mostly is, okay, let's put the cache between the application and the database. Then you can run a distributed cache like Redis. So this is very common. And many people tell me, hey, we have to save money. So which means memory is expensive. Our machines should be really tiny. So 2 gigabyte memory, this is really the maximum. But under the hood, they run a distributed cache cluster, which means you need a lot of CPU power, you need a lot of memory, of course. So you hide your memory in another layer. And then you have the storage layer, and in a microservice world, you have a lot of services dealing with completely different data. Some services are dealing with structured data, some dealing with no structured, with unstructured data. There is might be a microservice consumes sensor data. You need a time series database. Some services deal with really complex data. They using a graph database. Some of your services they execute some machine learning algorithm. They need a vector database. And so you need multiple database systems. And then in our customer projects, we saw a lot of Elasticsearch because of, and the question was always, you have a great database. You pay a lot of money for database vendor. So why you're using a searching server? Because your database, you tell me your database is great. So why do you need a searching server? And well, if you have bigger joins, your performance will go down. Searching server is really powerful. So let's add another cluster. So this is a common architecture. You run a lot of clusters, a lot of machines, a lot of memory, and for only one big data application. It depends on the use case, of course, but this is really common. And with Eclipse Store, we will change this, because Eclipse Store is a persistence framework that enables you to store, to build any object structure, any object graph, using any Java types, use collection, whatever can be used in Java. And Eclipse Store can store it because of we serialize your object graph and store it directly, persistently on disk. This is a really simple principle. And a lot of developers told me, I had this genius idea 10 years before you thought about it. So a lot of developers had pretty much the same idea. But there are some challenges, or there are a lot of challenges by just serializing your objects to disk. And with Eclipse Store, we solved all of these problems, by the way. So we replace object relational mapping or data conversion. So if you use a NoSQL database, you have no object relational mapping anymore, obviously, because probably you use a document store, a key value store, a document database using JSON, for instance, then you have a JSON conversion. But the same through every single read and write. So we replace this with Eclipse Store. And with Eclipse Store, we focus on memory. We keep everything in memory. I have to be careful. We don't keep everything in memory, of course. We don't keep the whole database in memory. You can do that if you have a lot of memory, but you can also run only a machine using 1 GB memory, or it works with Lambda, 500, 250 megabyte of memory. This will work, basically. So you keep data in memory, you search in memory, which means you keep the hot data in memory, and same what a cache does. Keeps hot data in memory. So we don't need a cache anymore. We can skip the local cache. And we skip complexity. And we are able to serialize your objects to everywhere, to any storage that is able to store binary data. So you can use plain files. And we recommend to use an object store, provided if you run this in the cloud, then you want to be cloud native, which means you use the native components of the cloud vendors. So it's recommended to use an object store like AWS S3, and all cloud providers provide pretty much the same. They call it object storage or blob store. And the cool thing is 250 gigabyte costs you only $80 at AWS. That's it. We don't talk about 5,000 or 3,000. It's not a question if you find really a machine, a provider that provides you the machine for $2,000, saving some more bucks. We talk about only $80. And there is no more replication, no more backups needed there. So it's the provider cares for that. They care for 99.999.7% uptime. So you don't have to manage this. Everything is done by the cloud provider. So we combine the power of the programming language, we combine the power of and the performance of Java, and also the flexibility of Java with low data storage costs, with low object storage costs in the cloud. And this is also very important. We store objects, and we can, as I mentioned, we can process any kind of data with Java because we have a multimodal data structure, which means it's not limited to a specific use case. So with the database, you're limited to the data structure of the database. It's built for a specific use case. And this is the reason why the database vendors, they tell you, so this database is built for consuming sensor data. It's built for graphs. This is built for vector machine learning stuff. Java can deal with everything. Eclipse Store just serializes your objects to disk. So this is not limited to a specific use case. This is very important to mention. But of course, there are cons. With all technologies are cons. But let's talk about this later on. Or no, I forget it mostly. So the cons are you have to think different. So please forget everything you have heard about how to program with the server database. Now, there is no more database, so please forget everything. And this is, for Java developers, mostly the biggest challenge. Yeah, because of we learned it, we're using relational databases for 20 years, so how can I forget this? But remove this from your brain. Think like a Java developer. Just think object-oriented. That's it. You don't have to learn Eclipse Store stuff. Don't think Eclipse Store specifically. It's not mandatory. Think like a Java developer. Think object-oriented. And we are able to replicate. So the framework, the library, Eclipse Store runs on a single JVM. It's built for a single JVM. But we are now able also to replicate the object graph through multiple JVMs. We distribute all store operations through multiple JVM processes to replicate your application or microservice through hundreds, even thousands JVM nodes, JVM processes, or server nodes, or Kubernetes pods, whatever. So we replicate it through the multiple JVMs. You can use it for caching, you can use it for searching, so we don't need all of these cluster solutions. Don't need a distributed cache anymore. We don't need a search server anymore. You can combine all of this. In microservice architectures, you don't have to make this decision for your whole application. You can make this decision for every single microservice. Probably it's mandatory to keep your Oracle database. This is not a problem. You can keep it. Probably you have some services you need more performance for these domains, for these services. Then use Eclipse Store. Try this out. Check it out. If it works for you, then you can combine it. And the cool thing is you can also use existing, or you can use traditional databases to store your binaries. It sounds a little bit crazy, but it's possible because PostgreSQL database can store binaries, which means we have a connector for PostgreSQL. You can use PostgreSQL as your data storage to store the binaries. But keep in mind, there is no more object relation mapping anymore. It stores only the binaries. And if you really have a look on your tables, you only will find some blobs. There is no relational data structure. Why you should do that? Sometimes organizations, companies have some policies, some rules. Yeah, we have to use this vendor because we have contracts, so we have to use Oracle. Okay, then you can use your Oracle database to store the binaries. It's not a problem because Oracle does pretty much the same. They also provide libraries storing binary data in a relational database. So in a distributed environment, we replace the application cluster with an Eclipse Store application cluster. We store data in a cloud object store, so we can remove all databases, can use complete database clusters. We don't need it anymore. We can deal with all data structures, so we could, in theory, remove all databases. And we can do everything with Java. We don't need caching anymore. We don't need searching anymore. And here's a plain architecture. And now the question is, if you remove all of these clusters, all of these machines, all of these CPUs and memory usage, please invest a little money in running bigger memory machines for your Eclipse Store application. This will not cost too much money. You will still save a lot of money, even if you run Eclipse Store instances with 16 gigabyte memory or 32 gigabyte memory. This is really okay, and it's not really expensive in comparison to run all of these clusters. So invest in a little bit more memory, because we talk about in-memory data processing, and in-memory data processing without memory is actually nonsense. But if you like, you can do this. You can run your nodes with only 1 gigabyte memory, even if you have a 500 gigabyte database size. Basically possible. Here we can see this is an application cluster. So we have the database actually inside your in-memory. So your graph, your object graph in memory becomes your in-memory database, because we search and filter on the object graph. You have an embedded database, distributed, stateful. If you prefer running stateless, or you need to run stateless services, you can do that. Then you can use Eclipse Store cluster to query the Eclipse Store cluster by REST, and then you can query the Eclipse Store cluster with any technology. You can write services in Python, .NET, stateful serverless functions, for instance. This is possible, and you can query or you can have access to the Eclipse Store cluster by using REST or GraphQL. And this is also the answer for the question: how can third-party application have access to my Eclipse Store application? Just use REST or GraphQL. And a cons might be there is no SQL support. Okay, this is the price to pay. But we already have discussions about, and yesterday there was a question in the chat, if there is any implementation already existing to execute or to enable writing SQL code that executes Java streams. So we already talked about this. and we work on this. So we made a little research about this. Let's see what comes in the future. And for this Eclipse Store cluster, we will provide a full managed service that you don't have to deal with Kubernetes stuff. But Christian will introduce this approach today, and you will learn about more in Christian's session. So for the rest of the time, 5 minutes left. So here on the website, you can try this out. And this service will enable horizontally scaling. The functional principle is simple, so I'll just talk about the functional principle. So the cluster will allow you to start a fixed amount of nodes, so you can configure. I want to run three nodes or 5 static nodes. This is simple, but what we want to provide is elastic horizontally scaling. So which means if a load goes up, then the environment should automatically start more machines to distribute the load. And to be more cost efficient, and if a load goes down, you will burn money. So the cluster environment should shut down nodes that are not needed anymore automatically behind the scenes. To be more efficient, to be really cost efficient. And if your cluster does nothing, it should scale to zero cost. How it works basically, the functional principle is very simple. Just need a Maven dependency. You just need pochos. The code is very simple and straightforward. There are no rules, no requirements to your classes, no interfaces to implement, no annotations, no superclass, just pochos. If you have already classes with your Hibernate annotations, you can keep it. This is trouble-free. But when you start from scratch, just write plain Java classes. That's it. The only thing you need is a database instance and a storage. Create this, and then you need a database instance, a starting point of your database. So let's create a database instance. So we have now a storage where Eclipse Store is able to store the binary data. Then we need a root instance. Imagine this is a kind of like a swing tree. So we have a root object, and all objects that are reachable from the root can be persisted. So now I want to add some objects here. And to store objects, by the way, this is only one store method. And this is so we did not completed the initial vision already. The initial vision was actually the environment cares completely for persistence. I have to do nothing. But this is a little bit challenging. You have to do something. The only thing you have to do is storing, to decide when to store. And we wanted you guys to have control of this. So this is the only thing you really have to decide, when to store objects and what objects you want to store. So I create some new object instances in the memory, and then I call a store method, and then Eclipse Store creates a snapshot, a binary representation of your object by using the Eclipse serializer, and creates a binary data in a file storage. This is how it works. I create some more objects, call store method, and I get another binary. So each store is a new binary, and this operation is transaction safe. This is an all or nothing atomic operation, transaction safe, and full consistent approach. So it's guaranteed that it's really stored in the storage. And even if you change objects, it creates a new binary. So every database operation is a new binary in your file storage, which means your file storage grows more and more. But this is not a problem because we provide a kind of like garbage collector for the file storage that cleans up your file storage behind the scenes and reorganizes also the data, the files in your file storage automatically. Don't have to care for this. And it's not a problem. It's a little bit the functional principle similar to what data streaming does or event sourcing, but in comparison to event sourcing, we do not store the event, we store the state. So I mentioned already, updating objects is the same. So we update an object, store it, and it creates a new binary. When a system starts, so this is very important. Here is my storage. When a system starts, then the Eclipse store will load the whole object graph into the memory. The whole or all information about your, this is more how it works. It loads all information about your whole object graph into the memory. So the storage, so the engine knows about of your entire database, but no data are loaded, only the object IDs are loaded. And now the magic begins because there are no more classic selects. So I promised you everything is covered by the environment. Just call get methods. There are no classic selects anymore. You wanna read customer object from a collection, just call a get method, get customer. And if the customer is already in memory, you get the object from the JVM. If the object is not in memory, Eclipse Store will load the object reference. So it knows where to find the binary representation in your storage and loads the object reference. It merges directly the object into your object graph. And you get the object defined. Or you let the JVM garbage collector care for the memory management. So this is how it works. Queries, of course, Java Streams API, and if something changes in your classes, we have the type mapping, and Florian will go into more detail how it works, what happens if the classes change. And so there are a lot of questions coming up. What happens if this and that? So all of these problems are solved. If you have really huge collections, you don't want to load all the data in memory. We have pageable collections. You can create in your own index. You can use Lucene. You can combine Eclipse Store with all libraries existing in the Java ecosystem. This is the great thing. We don't have to think to reinvent everything again and again. So you can use everything, every concept, design patterns, libraries, frameworks that are available in the Java ecosystem. And one last point is everything is done on the object graph. So we have to deal with concurrency. That's true. So, but this is also not a problem because you can use all Java concepts to handle your concurrency. All right, so I ran out of time. I'm over time. I'm sorry for that. So this was a basic introduction about Eclipse Store. After I have some more slides, of course, but this is all for the introduction. So after a 5-minute break, Florian will continue with how to get start coding. You see a lot more code, how this works, how the code looks like, and how simple is it to implement. So I will stay here to answer the questions in the chat if there are questions here. So please ask as many technical questions as possible. We're looking forward to answer your questions. Thank you for joining and have a great day at JCON, last day at JCON, and the Eclipse Store Summit. Thank you so much. Bye-bye. Have a great day.